Okay, so compound prism. Just describing the part that I think you're saying you're having trouble with, I'm going to find slightly difficult. So I'm just going to go through an entire question and explain everything, because the way I visualize things is a little bit different from other people by the looks of it. So I'll explain my whole process, and then that should explain the part that you're struggling with as well. So it all starts with this little diagram. Very simple. Eye, nose. That's the easiest way of doing it. That's also going to help with prism directions, knowing which is in and out. If you're doing simple decentration, P equals CF, so decentration, I visualize it this way as well. Now, the biggest mistake to not make is to label it as we see it, left and right. I know it sounds pretty obvious, but obviously it's as the patient's looking at it. That's very, very important for what he's saying. Was it that? Is it minus 360? Is it what? So it's very important to know which is right and which is left, and it's as the patient's looking at you. So you draw one of these diagrams for either side, and all that's going to be is your 0 degrees, your 90, your 180, your 270, and it always goes clockwise. All right, so clockwise is going to be easy to remember. That's what we said with hand note as well. Always start clockwise. So you go your 0 here, 90, 180, 270. Up is always up, down is always down. You don't have to include these in the diagram, but just again, it helps with visualizing it. But it's exactly the same as the eye. You can draw these diagrams to match the eye you're doing. Obviously, in on the right eye is the opposite to in on the left eye. Alexa, stop. Yeah, so you know which way is your ins, your outs, all that sort of thing. Your right eye, this diagram is going to be different to the left eye in only one way, and that's which side is in and which side is out. All your degrees all start in the same place, still goes clockwise, up and down are still in the same place. Okay, so with that in mind, I'm doing a simple example question. So compound 3 base up, 4 base out into the right eye. So we do the diagram this way, remembering our little eyes. We know out is on this side, in is on this side. So let's have a look. 3 base up, we're going to put 3 about there, I'm going to put 4 about there. So I'm going to have to put my phone down while I match them up. Okay, yeah, so you've got your origin. This is where the meet is R for resultant prism. Then I'm just going to make these two meet as well. And then we just chuck a wee arrow in here, just to know which way it's going. Okay, so your compound prism, the actual prism value itself is going to be OR. So OR, this is where you chuck your Pythagoras in. So we know that up is 3, and along is 4. So OR, that line is OR squared equals A squared plus B squared, or you can write it for yourself V and H if it's easy to remember, vertical or horizontal. But either way, you've got OR squared equals 3 squared plus 4 squared, which I can already tell you OR is 5. This is a 3, 4, 5 triangle. But yes, OR squared equals what? 9 plus 16 equals 25. Root 25. OR equals 5. All right. Nice and easy. So we know this length here, we now know is 5. Okay. So so we'll put that as 5 base, or 5 prism. Now the base, that's the next part. All about the base, as Sally says. So what you're wanting to know, you're not wanting to know this angle here or this angle here. All right. What you're wanting to know is clockwise, starting from 0, clockwise to R. So you're wanting this angle. Okay, this one here. Now, this is where I cheat. So all you actually need to do is ignore what I just told you. We're going to find this angle here. All right, because that's the nice, easy one. You can throw Pythagoras in there. So you get your SOHCAHTOA. personally, since you've got all three elements, you don't ever need to use anything else. All right, I always just use sine because it's the first one. If you only had two measurements, you might have to use cos or tan, but since we've got all three, I'm just going to use sine. I always do. So sine opposite over hypotenuse. So the opposite of this is this side here. So this side up here is going to be exactly equal to this side here, because these are identical triangles. So opposite is this one. So that's also 4. So we've got, so that is 4 over 5. Obviously, the hypotenuse never changes to 5. So what we've got is 0.8. So you're going to do inverse sine of 0.8 to find that little angle there. So we're going to do that. Where is my sine? There it is. Which gives you 53.13 degrees. So that angle, if we call it alpha equals 53.13 degrees. Okay, so we know this little angle in here is 53 degrees. But to learn this big angle here, all we have to do is 53.13 added on to 90, because we know this is exactly 90 degrees here. All right, so that actually equals 143.13 there. So you just notate that as 1. So you got 5 prism. I've got it written down here just to make sure I get the right. Yeah, 5 prism base 143.13, and that's it. That's how you know your final answer is that. If, for example, I'm just going to do this really sloppily because it's not going to be drawn with a ruler, but say we had the same sort of thing here, and we find out this angle is 40, for example, you would just do that again, opposite over hypotenuse, whatever, do your sine, say that angle was 40, then I would do, this case, you'd be finding this angle here, because again, you're always starting from 0, so be 0 going all the way around till we get to here. So in which case, it would actually be 270 plus whatever it was. So you could, in theory, say that it is 310. But you know yourself, you wouldn't really normally note it like that. So just like obviously axis and any set of specs, you would never go for 360, we always do it to 180. So you can whack 180 off of that if you want. Technically, writing 310 isn't incorrect. It's just not standard notation, so you would write 130 instead, because obviously that take 180 is that, because it's all the same line. Now that last part with the 270, I've possibly confused things more than helped, but that is just sort of helping to show I'm moving from the point of 90. Rather than finding this big angle here, you just find a little angle, add 90. Or if it's on this side, you find a little angle plus 180. Or then you could take off 180, whichever way. Does that make sense? But just find out whatever the big angle is, and if it's whether it's 310, whether it's whatever. But I always find you need to start from 0 and work all your way around. That's the way I do it, rather than going either side of 180, because yeah, if it comes out here, then you would do, like, what is it, like 180 minus that, and that's 180, no, 180 plus that, fuck it. Yeah, I find that way more complicated than anything. So yeah, you just always work out your big angle from 0 around to your OR, your origin to your resultant prism. And then if you come out with a big thing above 180, just take 180 off of it. And that's how you'd get your right answer. So hopefully I've cleared things up and not confused you. If you've got any questions about that, just give me a shout. I know the more I've drawn on this as I've gone on, it's probably complicated more and more, but if you rewind to back when it's just drawing it as and when I needed to. Hopefully it's going to make a bit more sense.